Hi, today we're going to take a look at properties of an isosceles trapezoid. So what makes a trapezoid a trapezoid? Well, it's a four-sided figure, a quadrilateral, that has one pair of parallel lines on it. Those parallel lines we call bases. The other two sides we call legs. Now, those legs, in order for it to be isosceles, has to be the same. Now, like a triangle where you have isosceles legs, opposite vertices, the angles, they're also the same. In here, same thing. These two angles are congruent to each other. These two angles are congruent to each other. Now, one last thing that happens within a trapezoid, or specifically a isosceles trapezoid, are diagonals. The lines that go from corner to corner, vertex to vertex, angle to angle. These two diagonals are also congruent with each other. So they have the same value. And then what's also neat is it's not going to be that this line and this line are the same, but rather this portion on the bottom and this portion on the bottom are the same, and that are going to be the same. They're going to be all congruent to each other. So let's use this information. Let's come over here to figure out what we got going on. So we have to find a lot of stuff. I don't care about this. Let's just come over here, label our picture, and then label everything else that we can find on it. So first, measure of ADC. ADC. So our big angle right here is going to be, put that in the middle, 85. Okay? DAC. DAC coming down. Just that little corner is going to be 55. Okay, we know that AE is 19. And BD, the whole thing is 55. Okay, so how can we write that on there? So 55, we'll say that. Okay, let's label everything else we know within this picture. So, like a parallelogram, we're going to have 180 degrees with consecutive angles. So we already know 180 minus 85, taking this little section out, leaves us with 95. I want to take that out, so let's take 55 away from that, and we're left with 40. There's your missing angle up there. So now if I were to take these two consecutive angles, add them up, I'm going to get 180 right there. Okay, so isosceles, things are going to match up. Things are going to be the same. So if I have 40 there, that's 40. If I know 55 here, this angle has to be 55. Down on the bottom, I know this whole thing is 85, and I just leave it like that. What else do we know? AE is 19. BE is 19. If BE is 19, and I know that that's 55, this section right here has to be 55 minus 19, which leaves us with 35, 36. That's 36. Then this side also has to be the same. So we just marked up our pictures all over the place. That's great. And that's only given two angles and two little pieces of our diagonals. Let's use all this, fill in what we have here. BE, we already figured it out, 19. EC, from there to there, 36. BAC, BAC, so that corner is 40. ACD, ACD, interesting. So I didn't do that. Okay, let's kind of come back for a second. So we missed something because we knew that this whole side was that whole vertex was 85 and this one's 85. Now, since we have parallel lines, and so parallel lines, top and bottom, we also have a third line, a transversal that cuts through them. If you go back to the beginning of geometry, some of the first stuff that we should have learned, we have things called alternate interior angles. If I know that this is 40, coming all the way down, this angle also has to be 40. So what is ACD? ACD, that's got to be 40. Leaving this side 45. BCD, BCD, so the whole thing, 85. BAD, BAD. So the whole angle would be 95. ABC. And that's going to be the same thing, 95. Suggestion, let's label our picture, fill in everything we can, and then everything else just kind of falls right into place. And that's using the properties of isosceles trapezoids.